Okay, our next speaker is Jun Liu. He is the Senior Marketing Manager at Revvity Signals. He is responsible for industrial chemistry segment marketing at Revvity. He has over 10 years of marketing and business development experience in the specialty chemical industry and worked as a software engineer in the semiconductor industry. He has an MBA degree and an MS in electrical engineering from the University of Texas at Austin. He also holds a BS in computer engineering from Michigan Technology University. His talk title is Using Big Data and AI to Accelerate Specialty Chemicals Products Development. And welcome, Jun.
All right, thank you, John. Good morning, good afternoon, good evening. Let me figure out how to share my screen first. All right, now I can share screen. All right, hi everyone. As John mentioned, today I want to talk about AI and the big data, AI related topic, and how AI and big data can help formulation development, especially in the chemical industry. So I want to organize my talk in the following steps. First, I want to introduce Revvity Signals software company. And then I want to explain a little bit about AI. Dr. Mueller did a wonderful job explaining how AI can be used in simulation, multi-modal type of analysis and the material property prediction. I want to go back to the very basic of the idea of AI. And now I want to introduce a little bit about our products. And also I want to walk you through a AI-assisted formulation workflow in action. So Revvity Signals, we are a software company. We make a variety of scientific data management softwares to empower scientists to do their job better. So our success is built on decades of experience helping scientific community to find answers. Our customer base covers a variety of disciplines. As you can see, and John mentioned, I'm in charge of the marketing activities specifically for the chemical space, material space. So in this space, we support coating companies, polymer companies, personal care products, and oil and gas derivatives companies to do their formulation better by providing them a platform to organize and manage and analyze their scientific data. And we have been around for more than 20 years. And today we are more than 700 passionate individuals trying to help scientists do their work better. Our flagship product is Signal Research Suite. In that, we provide Signal Notebook, which is a scientific data management software, or people like to call it electronic notebook. And then we also provide Signals Inventor, which is the analytical engine. Scientists can use notebook to manage data, and Inventor will help convert that data into graphs, into knowledge, into analysis. Signals Inventor is built on top of Spotfire, a very powerful scientific data analytical engine. And as you know, we are the original inventor of ChemJoule. Today, ChemJoule is natively and seamlessly integrated in our Signal Research Suite. And our latest addition to ChemJoule is Signals ChemJoule, which is our most modern and cloud-based ChemJoule system. So let's talk about AI, right? The first question is, what is artificial intelligence? Right? I think in plain English, we can say AI is basically a technology that enables a machine or a computer to learn and perform human-like tasks. So we enable a computer to think like a human. And so what are some of examples of these tasks? I think we started AI by programming our computer to play chess. I think that started maybe 20, 30 years ago. And the human we lost the battle of playing chess probably 10, 15 years ago, right? Remember when Deep Blue beat our best chess player in the world. So behind that is AI. So AI is not really new. We started to play with, started to have this technology perhaps 20, 30 years ago, or even longer. And what made AI very exciting or scary at the same time is this autonomous vehicle technology. Companies started to talk about self-driving cars about 10, 15 years ago. And the latest Tesla released the FSD version 12.123 or whatever, and it really pushed self-driving to the very forefront of people's driving experience. And then behind that is AI. It's very, very powerful, very complex AI in the background. And also last year, large language model or ChatGPT type of AI really made AI every dinner table's conversation. And that's when a larger population realized that, hey, AI is here. I mean, whether we accept it or not, it's here and it's everywhere. And it's going to be even more for daily life go in future. So what is behind AI technology in a very plain term, right? We say, okay, we enable a computer to think like human. How do we think? Well, how do we think is actually a very, very complex question. I don't think scientists today really understand how humans think. But how do we make a computer to think like human think is actually a rather simple, not simple, but rather straightforward process in terms of the data flow. So for computer to think like a human, the first step is for computer to recognize pattern. Computers are based on numbers, right? Computers don't have eyes, don't have ears, don't have smell. So they recognize patterns by abstracting that pattern into some of numerical format that the computer can recognize. So they recognize numbers. And then the second step is based on that pattern, computer can make a decision, recognize, okay, this is a person, this is an animal, or this is a word, or this is a sentence, and do that. And then the third is after that decision is made, and the computer needs to make a judgment of that outcome to evaluate whether that decision made is correct or not, probability-wise. And of course, computer repeats this process many, many times. And we call this think like a human. So one example, I think it's good to explain this idea is, okay, ask this question. How does a machine know this is a cat? And human beings, we look at this picture, we immediately know this is a cat. But how does a computer know that? I mean, first, computer does not. Computer cannot interpret this picture the same way as human beings do, right? So first task is to abstract that picture or convert or transform that picture into a mathematical representation that computer can take further. Usually you take some layer of this picture information out, let that be pixels, colors, right, shapes. You convert that into a mathematical representation. Usually is in the form of a matrix, a two-dimensional number format. And then computer can take that and then pretend they can think or they can analyze that. So there's a lot of mathematics behind the scene for computer to make a judgment whether this mathematical representation of this cat picture is some other form of cat mathematical model that the computer had been trained before. So there's a lot of calculus going on because pictures have to be transformed. So technology like Fourier transformation is often used to transform this visual representation of a cat to a mathematical representation of a cat pixelized picture. And there's a lot of linear algebra involved in this process because we, as a human, we see the cat picture is upright. We can tell that, but computer doesn't have this concept of what's up, what's down, what's left, what's right, right? So a lot of pictures have to be rotated or scaled. There's larger picture, there's a smaller picture. Yet humans, we can say, okay, this small picture looks the same as the larger one, but the computers may not be able to do that unless we apply certain linear algebra operation to those matrices. Therefore, computer can say, okay, these two pictures resemble each other. And then lastly, probability is a big part of this because humans, as we think, we say, okay, yes or no, right? 100% or 0%. But computers, everything is probability. So probability, computer will tally up the pixels of some matrix and say, okay, this one looks 80% like a previous cat picture or representation, therefore this must be a cat. So calculus, linear algebra, and probability or statistics make the backbone of AI technology. And also, computers don't just take a look at one cat picture and then compare it to another one and then make a decision. Computers are trained on many thousands, perhaps millions of cat pictures in order to make this judgment. Some of these cat pictures will look like a skinny cat, will be fat cat, angry cat, flying cat, you name it, cartoon cat. The more computers are trained, the better, the more confident the computer will have in making a decision whether this picture is a cat on that picture. So as you can see, it's a rather complex process for a very, very simple task humans can do in milliseconds. And yet there's still a challenge, right? I mean, does the computer know this is a cat? I mean, right? I mean, we leave the answer to another webinar. Luckily for the chemical industry, material science industry, we don't have to get into the philosophical debate on whether tiger is a cat. There are two, I think, most relevant AI use cases in this industry. One on the left is built around the most advanced output of AI technology today, ChatGPT or generative AI type of technology. I believe generative AI technology can really enhance the search experience, which sits at the foundation for a lot of scientific discovery. By search, I don't mean the strict sense of keyword search. I mean connecting knowledge and finding what knowledge is relevant to scientific discovery, that in the broadest sense of search. So AI can make search much more intelligent, much more humanized. We'll be able to search just like we speak to each other. As Dr. Mueller said, graphic-based search, either input or output, AI is capable of doing that and make search more conversational. And also on the higher level, AI can enable R&D team to both summarize somebody else's research or summarize their own research, generate a report. As we all know, right? In a company, R&D activity is probably, I would say, maybe 50% real scientific work. The other 50% is really reporting. I think AI can really help to remove some of the burden of reporting scientific discovery, reduce that burden and make R&D work much more efficient and more pleasant. And the second area is really, I call this predictive analysis or DOE or many names for it. That goes back to the very core of AI technology, which is statistics modeling. And that's nothing new. I think statistics, the field of statistics probably has been around for like 500-600 years, right? So that's really to help reducing formulation space from universe to our solar system, set boundaries to establish DOE, reduce the number of trials, experiments, and then find insights, reduce experiments as much as possible, therefore making discovery work more efficient. So on search and on predictive analysis, I see AI has the biggest potential to impact scientists' lives. But companies don't just say, okay, we have AI, or we are AI enabled, or we are AI, right? In order to get there, you have to build a pyramid for AI technology to really thrive. And that starts with building a foundation, which is having this structured data capturing ability. You have to have the big data infrastructure in order for AI technology to succeed, right? Without it, there's nothing, garbage in, garbage out. If there's no cat picture, there will be no cat recognition technology. So building that cat picture database is really important. And then the second step is you have to realize there's a lot of domain expertise already in the chemical industry or in any industry. So building this friendship or building this coexisting environment culture is really important between scientists and the AI technology. So people and machines don't go to war against each other, but rather help each other to make better formulations. That's really, really important because AI technology is new. To some people, it's really exciting. It's going to change the world for the better. But for other people, it's scary because we still don't know what boundaries, right? We still don't know what limitations of some of the AI technology to have. So having, building that culture, setting boundaries, and educating staff members about AI technology is really important. Only when a company does step 1 and 2, I think the company is ready for AI, and the AI can really flourish. So at Revvity Signals, and our aim is to help R&D organizations build the entire AI pyramid, not just focus on the very top of this pyramid. So as I mentioned, Signal Research Suite is our flagship product. Signal Notebook and the Inventor are the two main components within Signal Research Suite. So the value we deliver to R&D team includes foremost increased team productivity, and also because we give the team a platform where they can really connect the data, connect the knowledge. Through that, better products can be developed, and also peripheral benefits include reduced compliance risk, because finally we have a database that captures not only performance-based data, but also compliance and also sustainability related data. So better decisions can be made and the team can collaborate. So we deliver those values by, even without AI, in these four categories. First, we provide a unified, de-siloed database. So your data is no longer sitting on a paper notebook or sitting in different files in Excel type of environment. They are unified, they are structured, they are sitting there, they're ready to be taken to the next stage. And we also provide strong search capabilities, so knowledge can be searched in seconds. We also provide a collaborative platform because multiple scientists and technicians can share this platform, send a message to each other, issue tasks to each other, review each other's work, and collaborate. And at the end result is we help R&D organizations to accelerate product development process. And with AI, I think we really can enhance these four capabilities big time. With AI, not only we are talking about unified data, we are talking about unified and connected intelligence, chemical intelligence, biological intelligence, right? Formulation intelligence. It's not just the keywords are connected, but this knowledge are connected through AI technology. And we can help teams summarize research results and really help scientists not only dealing with the numerical part of their research, but also the entire contextual or metadata around an experiment. And AI can significantly help search to make it more natural language-like, make predictive search, right? I think the big challenge of search is really helping the person who is searching for something understand what exactly is the person's search, right? And give the person some hints on what's coming next. And AI will really, really help on that. And also, a big part of search is really the result. Result first needs to be human readable, but also result needs to be further processable by the machine. So they tabulate that search results and make some recommendations on what to do next. On collaboration, AI can predict what's coming. So let's say if a formulation table is made, AI can jump in and issue tasks to assign, okay, technician A make this premix, technician B does this work, and technician C check the results. This type of work, AI through generative AI technology, is all possible. And detecting error and also image generation and recognition, right? If through testing result, either if there's a image of certain testing result, let's say if you make a mix of liquid and viscosity is too high or too low, and AI may be able to find that through just image recognition. So that's where AI can help. And because AI and also on accelerating product development, this comes to the core of AI technology, which is curve fitting, which is linear algebra, which is a lot of powerful statistic capabilities. AI can really help predict chemical reaction, which is something ChemDraw is we are looking at today. And also, as I mentioned earlier, AI can help automate report generation and really help the team to apply the best statistical model to a experiment, basically humanizing the multi-parameter analysis. Because we know scientists have different disciplines. Not everybody is trained a statistician and might not outsource some of that statistical modeling work to AI and then let AI help us finding the right statistical modeling method to carry on research. So our products, we design our products to support the entire new product development workflow that starts with synthesis work or formulation work, and then we carry through to help analytical testing to collect and organize testing results efficiently, and then team can eventually bring the product to scale up and eventually to customers. The reason we understand this workflow very well, and we design our products to provide capabilities to support each stage of this flow. So in our system, you will find experiment data management, which is the core of electronic notebook. And then we complement that with inventory and material management system, because formulation work is not just about keeping track of each experiment, right? It's about making a sample and then finding ways to test it. So a strong material and inventory library or management system is critical to that formulation work. And we also provide the team the capability to connect to instruments to collect that data. And then finally, our Spotfire-based data analytical system, I think, is the most powerful scientific data engine out there. And for all these capabilities, in order to extend our system, we also provide team APIs, advanced programming interfaces, and the system integration capability to really extend the power of Signal Research Suite. So combined, we want to create a R&D workflow digital twin to really accelerate that process. And we focus unwaveringly on streamlining this R&D workflow, starting with brainstorming solution, step one, carry it all the way to sample making and results analyzing, and then eventually to scale up. So we also provide a very intuitive R&D data platform. As you can see, the three screenshots here. The middle one is the dashboard. This is the entry point for a user to log into the system. This is a highly configurable dashboard where scientists can list their interested projects or status or even research reports from various internet sites in this on this screen. And then on the left, you can see a snapshot of our search capability. We provide very strong, fast, AI-driven search capabilities where scientists can find relevant or interested experiments or samples or tasks in very, very short time. And also on the right side, as you can see, this is where scientists can keep track of tasks. So dashboard, search capability, and a task management, they are very, very intuitive to use. And then when the team is ready to get a formulation, we provide a very strong formulation management or tape. In this example, is the picture in the middle. It's basically a powerful Excel-like table manipulation capability where team can specify ingredients to a formulation, get relevant data out of either within material library or extend it and get it out of a third-party data system to make the formulation table. And then from there, formulation table, we recently added very powerful calculation features. So now it works somewhat like Excel, giving scientists the freedom and the flexibility to perform the formulation work they intend to. And also there's variation table capability where basically a scientist can copy paste from one formulation to multiple ones to build the foundation for a DOE. And behind the background, every change is tracked. So the team can always go back and do an audit and then look at and then trace and repeat this work. And as I mentioned earlier, formulation without inventory management system is weak. So we provide a strong inventory and material library to enhance the formulation table. In this example, not only the material information is kept, such as SDS information, but also we provide a physical inventory tracking capability where if a technician takes out a bottle of certain ingredients and then put that information in the system, we automatically reduce the inventory level of that ingredient to that physical location. And on the right side, you can see it's blocked by the main screen. That this is what a task looks like. Because in order to perform this flow, different stages, team needs to issue tasks to various team members and then review their work. We provide a system that enables that entire workflow. So we support multiple data formats. There's user data, of course, generated in Signal Notebook, and we also support equipment or instrument integration. So lab data generated by certain instrument, given that instrument is connected, that data can be integrated and used to analyze. And we also support external data sources because we believe data comes from various places. The more we can integrate every piece of data, the better we can later on use AI technology or just use human brain to connect the data points and make better decisions. And as I mentioned, Spotfire is the most powerful scientific data engine out there. As you can see, it supports many types of charts. You can do curve fitting. You can do multi-parameter in Spotfire in Signals Inventor. So combined, we give scientists a very powerful tool set to perform their work. And we're always on the lookout for the best technology out there, whether that's modernizing the user experience or providing the most up-to-date chemistry and biology intelligence. We only work with the pioneers of the industry. And we also understand we want to provide the best service to our customers, because technology without service, without the human touch, is not the technology that can really help our scientists. So we have a very strong service team. We want to build relationships with our users, with our customers, and we want to empower our customers to do the best work they can. So yeah, in the last minute, I want to walk through this formulation workflow quickly. So let's say this is a paint formulation lab. It has 4 types of people, 4 types of personas. There's a project director type of business type of staff member working on this, more like a boss. And then there's a formulator, there's technician, and then there's regulatory personnel. All these 4 types of team members, they collaborate on this paint project. From the start, the team can sit together and go through past experiments, past the knowledge base, use search and other features to build a starting point for this project. In formulation, we provide data table representation capabilities and calculation capabilities and variation capabilities for team to try out different formulations. When a team is ready to create a recipe, our experiment management system not only provide the tools to represent that formulation digitally, but also give the team the ability to track mixing steps. And behind the scene, all this data, all these columns and rows and data points, they are connected. They are sitting in a database that can be reused later. When in the sample making stage, Signal inventory management system can really help the team make samples efficiently and track them, understand the performance. Task is part of that capability. And then finally, in the analytical stage, Inventor, based on Spotfire, provides team very powerful statistical modeling tools where the team can build dashboards, can choose charts. And one advantage of Spotify is these charts are interactive. Basically, you can click on certain parts of a data chart, and it will lead to a more detailed analysis. Or you can select table, select the rows, columns, or just data points, and our software can instantaneously plot those data points for you. So combined, we give the team a collaborative platform where they can examine, they can debate, they can collaborate on every step of the formulation workflow. And we also provide the team to generate a report. So that when it comes to monthly review or bi-monthly review, we help the R&D team to generate that report. And then with AI, generative AI, I think those reports will be much more readable and much more comprehensive. And that's the end of the presentation. Thank you for your time. I hope I made it on time.
Thank you, Jun. We're gonna take questions. I asked for questions. We didn't get any. We'll take the questions that I have into the roundtable at the end of the day. Okay, we're a little crunched on time.
Yep.
Okay.
Good.
Thanks
Thank
a
you.
lot.